All right, welcome to another exciting episode of AP Chemistry here at Spain Park. Today is Thursday, March the 7th, 2024, and we're going to be talking about KSP problems. And if you're enjoying these videos, please feel free to hit that like button and subscribe to this channel. But in KSP problems, we've looked at the first three, and now we want to know, what did we say yesterday, that if it says will a precipitate form, what type of problem is this?
Q problem.
It is a Q problem, okay? So we have to, whenever you have this type of problem, we have to go through and look and say, how does Q compare to the given KSP? Now, whenever you have these problems, it is going to be a dilution problem as well as a KSP problem. Now remember, dilution problem is simple. It's what did you start with divided by the total volume you ended with. In this case, it's 60 plus 60, which makes it easy, because that makes it 120, means it's going to be half the concentration. But if it was 60 plus 30, then you'd say 60 over 90 and 30 over 90 is what the concentrations are going to be. It's just that simple. Okay, it's just a proportion, a relationship, a ratio, I mean. And so, since we've already done that one, let's look at this one right here. We'll kind of go, this is one on my page 6 in the packet that you have. Let's kind of just work through this whole problem. Let's see if we can do A, B, C, D, and E. A, B, C, D, and E. one, and now all 5 in that drawer are gone.
I still want it.
So don't you have to like take a square root of the sheet? Because you're giving it to us, and then you gotta divide by 0. What would you want? Yeah, I got x squared. Wait, hold on. This is, go back. Is that what you did?
So what was the square root?
They're all the same kind, they're all just like that.
So what was your answer, Rebecca?
I got 1.4 times 10 to the negative 50. Because you gotta do x times x. Like the bond x times x.
Yeah, I got that. Is it greater than the solution stirred? This should be even. Because an equilibrium usually is very.
No, because you're gonna have a bar. But this is, it's just the way it is. This is how it should be.
Yeah, so it should be equivalent. You just take distilled water, because all it's gonna do is just add it back into equilibrium, so all the concentrations will shift around. So it really tells you, it says solution is stirred in equilibrium with established, so the concentration shouldn't change.
Like, what's the difference between these all?
It'd be different if they were adding like AG plus, yeah, we have to do with the I think the minimum value is still the same. 5%.
Just take down.
says all the way down through E. Okay. E is what we really want to focus on, but the rest of it's still good. Concentration's gonna be the same no matter how much you have.
You just divide it by 0.02. This one's crazy. Even now, you should hold your. I just. Your hand to move to right.
Stop that. Focus on this.
Ow! It's just like crazy. Like, it's not really your fingers that do that. It's actually your hand. Making sure. I'm saying, if you hold it still, the arm stays still. Like your hand moves along. It's just, see, I'm gonna have to wait. Speed, that is the question. Wait, you divide by the sum of those things.
Oh, this is where you like 10.
Because you have to calculate your Q value. If Q value is less than KSP, then your distribution. We did it, it's the problem we did yesterday, but I didn't get it finished right, you know,
Wait, did you send it by myself? Pretty easy.
You just turn it in. Right?
Huh? No, because you have to do 10 plus 12.
Where's this from?
E. Look, it says 10 plus 2. 10 milliliters.
Oh, so you're saying 10 plus 12?
Yeah. Oh, it's
What? Where is this from? You're thinking too fast. Like, shout, speechless. Google it. Hey, stay over there. You're back. Yeah, that's too much.
Oh, so it's 9.
Right? Yeah, Yes. Right, here, scissors. What do you need scissors for? Just grab it.
Oh my god, it got more than 1,000.
All right, let's look at this. We don't have like forever to be able to do these. What would be the equation? Now it doesn't ask for this, but what would be the equation for the dissolution of silver bromide in water? AgBr solid goes to Ag plus Br minus aqueous. But we kind of have to know that in order to be able to do our KSP expression. So the KSP is simply going to equal Ag plus Br minus. Okay? Off to a good start. All right? So B, calculate the value of silver ion concentration in 50 milliliters of a saturated solution of silver bromide. What piece of information is what we would refer to as superfluous information in this?
Not needed. The 298K.
298K we don't need. But
50 ml.
Grayson, what? 50 milliliters, because if it's a saturated solution, will it matter if it's 50 milliliters, 100 milliliters, 1,000 milliliters? Will the concentration change at all based upon that?
No.
No. So the 50 milliliters is a distractor. It's just there. Because this is back in the day. They don't put as many of this type of stuff in there like they used to.
People that make AP tests for the spawn of Satan.
Okay? So really, we just want to go through. We know KSP is 5.0 times 10 to the minus 13 is going to equal what and what? What times? X times X, or X squared. So X is equal to my Ag plus concentration, which is also equal to my Br minus concentration, which is also the total amount of AgBr that dissolves. That's the concentration of AgBr. No matter how much you have, the concentration of a saturated solution is going to be that, and that value is equal to what number?
7.1.
7.07 times 10 to the negative 7.
So 7.07 is going to be 7.1 times 10 to the minus 7. Molar.
6 bigs, that's just 1 point off.
Okay? So we have 7.1 times 10 to the minus 7th molar. That's the concentration of, now they want the silver, so we really want to make sure that. Now, the reality is that if I wrote this, I did define this as the concentration of the silver. I added more than what I needed to, but this is the concentration of the silver. So you would, get your points even if you put all three of those. Okay, but always go back again and look at the question. If I was taking this test, I probably would have erased or scratched through, or just would have put right below it. I probably would have then said Ag plus is equal to 7.1 times 10 to the minus 7, just to make sure they know I answered the question. Now C. A 50 milliliter sample of distilled water is added to the solution described in part B, which is in a beaker with some solid AgBr at the bottom. The solution is stirred and equilibrium is reestablished. Some solid AgBr still remains in the bottom. Now, that's kind of a key thing, because that means it's still all didn't dissolve. So we still have a saturated solution. Is the value of silver ion greater than, less than, equal to the value calculated in part B?
Equal to.
Easy to say.
Okay, but you put more in and it dissolved. I mean, you put more water in. How come it's not less?
It's not going to change the concentration.
Because it increased, something's going to dissolve, right? According to Le Chatelier's principle, why is it going to shift to the right?
More mole.
Because you're adding water, correct? You're adding water, so it's going to shift to the side with more dissolved ions. Okay? That's one reason. Okay? Oh, you're taking your test. That's right, so, okay. I'll be right there. So we're going to Ag plus Br minus, so it's going to dissolve, but it's going to redissolve until when?
Equilibrium.
Equilibrium. Did we change the temperature?
No.
No, he's starting a test. And you probably are going to want to go next door so you don't have.
Jake Paul is such a good show.
Oh, is he fighting
Mike Tyson.
Mike
He's like
Tyson?
50-something years old.
I saw that.
That's like me fighting my grandfather. Like, that's messed up.
Dude, my grandfather.
That is so true. My grandfather would kill me 100%. He would take no mercy, but still, like, you gotta have like respect for Mike Tyson. One of the greatest boxers of all
Is he
time.
grandfather Brian?
Huh?
Is he grandfather Brian? My grandfather's like.
Hey, why did you
Oh,
invite
he's
me?
not. Yeah.
I used to play it so long ago, and I just remembered that it existed. No, that was so funny though.
I'm on 1,000 like 50.
I forget that they go like.
Candy Crush?
Yeah.
Candy Crush is so much fun.
I played different levels.
Dude, it's impossible.
It's not possible.
Yes, it is.
There are certain points where I'm like, it's just luck of the draw at this point. Keep going.
Yeah, I spent money on candy trash.
I feel it's not like a funny thing. Like, I spent $2,000. There's a TikTok audio somewhere.
Chop and spit money on the.
My dad's on like 3,000.
3K.
Yeah, and it keeps going.
And what's the sweat?
All right. So what do we come up with? What's the answer? Okay, let's get refocused. Roll all our stuff away.
Equal to.
It's going to be equal to, because we didn't change the temperature, the concentration is going to be the same. Initially, you're adding water, it's going to be more dilute. But they're saying that there's some on the bottom. The fact that there's some on the bottom tells me that more will dissolve. And they said some remains in there, which means that there was enough for it to get back to completely saturated. And saturated is always going to be the same concentration, whether it's 50 milliliters, 100 milliliters, no matter what, it's going to get back. That's very similar to evaporating the water off. Okay? So see how they're asking that question. Make sure that we're kind of keeping that straight. Now,
So it
Ca-
increased, decreased, or what?
what do we, what,
It stayed the same?
stayed the same.
Okay, that's what I put, great.
Stayed the same. So now D. A student, calculate the minimum volume of distilled water needed to completely dissolve 5 grams. Well, we have 5 grams of AgCl. Where do I go on this?
It's
AGPR.
AgBr.
Erase it and rewrite.
Moles.
Okay, change that to moles, and they tell you the molar mass, right?
Yeah.
It's 188, so I'm going to say times 1 mole, 188 grams. That's going to tell me,
Now we need liters.
now I need liters, and so what takes me from moles to liters?
Polarity.
The molarity, which we found that the molarity, the maximum that can dissolve, is 7.1 times 10 to the minus 7 moles per liter. So which way do I need to put that?
On the bottom.
On the bottom.
What goes on the bottom?
7.1.
So I say 1 liter, 7.1 times 10 to the minus 7 moles. So all, this is just a units thing. So moles cancel, that leaves me liters. It comes out to some very large number. And a lot of students this year thought that they'd done it wrong because it came out to such a large number. But they were kind of trying to make a point that it's not very soluble. And I'm not saying, no one's given me an answer, which means that nobody did this one correct the first go around.
37,000.
Okay? 37,000 liters of water
Fully make it all.
to get 5 grams of silver bromide to dissolve.
That's not that much, you know.
37,000 liters. Now, somebody divide that by, there's 3.76 liters in a gallon. So divide that by 3.76.
9,960.
So about 10,000 gallons of water. So what does that mean about, so when we see slightly soluble, I mean, we mean slightly, but there is some dissolving, so it's not insoluble, but it's very, very slightly soluble.
Anything insoluble?
Well, again, when you talk about something, we looked at those KSP values at 10 to the minus 49. I mean, there's some in there, but I mean, minuscule amounts. All right, so now we get to E, which is the part we really want to talk about. Okay? A student mixes 10 milliliters of silver nitrate with 2 milliliters of sodium bromide while stirring. Okay? So the first thing I have is silver nitrate plus sodium bromide. And what's that going to make? What's it going to make?
AGBR.
AgBr plus NaNO3. Now, which one of these would be a potential precipitant?
AGBR.
AGBR, that's the one we've been working with the whole time, right?
Right.
This one, all alkali metals are soluble, all nitrates are soluble. But the question is, will this precipitate form?
Unless it got 36.
How do we determine whether the precipitate will form?
Q.
Oh, Q is higher than,
Q.
is higher than K.
So, Hill, how did you guys, I saw you guys, I heard you talking about 10 and 12 and whatever. So, so what is my silver ion concentration going to be? Where's the silver ion coming from? The silver nitrate, right? So I have to look, well, I have my silver nitrate, I have 10 milliliters of 1.5 times 10 to the minus fourth, but is the silver nitrate still going to be this 1.5 times 10 to the minus fourth once we mix them together? How much of it's going to be? What's its concentration going to be before you actually figure it out?
Less.
How much less?
Oh, 1,000.
No.
No, 3.
10, but what's the total volume going to be? 12. It's going to be 10 twelfths as concentrated as it was before. 10 twelfths is concentrated. So the silver concentration is going to be 10 milliliters over 12 milliliters times whatever it was originally, 1.5 times 10 to the minus fourth. And so that turns out to equal
1.25 times 10 to the minus 4.
1.25 times 10 to the minus fourth is now my diluted silver ion concentration. What about the Br minus? How am I going to do this one then?
2 over 12.
2 over 12 times what?
Times 5.0 times 10 to the negative 4.
And that's going to equal 8.3 times 10 to the
Minus 5.
So what do I do now with those numbers?
Multiply them together.
To get
Q.
Q. Times my 8.3 times 10 to the minus 5 molar, and that all equals 1.0 times 10 to the minus 8. You said 1.04, right? Okay. Now, so what do I do with this value?
Compare it to KSP.
Compare it to the given KSP of silver bromide, which is 5 times 10 to the minus 13. So is Q bigger? Do what?
Yes.
PPT will fall off.
It's bigger.
Okay. Q is greater than KSP.
So then
1.0 times 10 to the minus 8 is greater than 5.0 times 10 to the minus 13. Therefore, what are we going to observe?
A precipitate.
A precipitate will form.
because there's more products.
Okay, now in terms of Q, Q is products over reactants. Okay? Products over reactants. So if Q is greater than KSP, we have our equation of AgBr going to Ag plus Br minus. Okay? So if Q is too big, that means we have too much product, not enough reactant. So if K is larger, it's going to shift left, meaning that we're going to have some solid forming to get Ag and Br minus the concentrations less to where Q equals K. Q is greater than K, it's going to go towards reactants. If Q, because that means the products are too much. If Q is less than K, that means the reactants are too much. It's going to go towards products. to get to equilibrium, to get to Q equal to K. All right? We good with that? Kind of? But notice again, y'all seem to just jump in there where there's a Q problem on this part. All right, let's look at our last type, which will be a bonus type question. I know, it's because we wasted so much time at the beginning of class. Me trying to get y'all not to jump out the window. Okay. Back to page 1. Back to page 1. Our lab is going to have, what do we got as far as Monday? Who all is not going to be missing on Monday? Who will be missing on Monday? Anybody? For what?
I'm going to my brother's match day for like next week.
Okay, so it's not school related, you're just missing. Okay? Alright, so then we're only down 1. That's a better percentage. Lab on Monday, because this is the lab basically that we're going to do. So now in this case, when we look at number 3, B3, if 0.1 mole of NaCl is added slowly to a beaker containing silver nitrate and lead nitrate. Now notice that lead chloride and silver chloride both form precipitates. Okay, they give you a KSP, they're both going to form a precipitate. The question is, which is going to precipitate first? Okay, so here's the picture of what's happening. Okay, so we have a distorted flask that has 0.12 molar silver nitrate. And with the nitrate's not going to do anything, so it's got 0.120 molar Ag+, and it's got 0.15 molar Pb+, 0.150 molar Pb2+. In a solution, floating around in there. Then we're going to use a burette, okay? And it's going to have some NaCl in it, and we're going to start adding it in dropwise. And the NaCl is given as 0.1 molar NaCl. Now, the 0.1 molar is really kind of moot in this problem. We know both KSPs. So what we have to do is we know this concentration. So given the lead chloride, the KSP is equal to, it's given as lead chloride 1.6 times 10 to the minus 5. It's going to equal the Pb2+ concentration times the Cl- concentration squared. Well, what one do I know? What do I already know? Because I'm adding these two things together. I know the Pb. So it's going to equal 1.6 times 10 to the minus 5 is going to equal 0.15 molar times my Cl- squared. So we divide this in, take the square root. Cl- is going to equal anyone.
I see 0.5 or
It's right here.
oh,
It tells me
0.1. I see it.
it's 0.12 and 0.15. Yeah. What does Cl- equal?
Got 1.0 times 10 to the minus 2.
1.0 times 10 to the minus 2 molar. Okay? So in other words, once the Cl-, as we're dropping this into here, once the Cl- concentration gets to this concentration, a precipitate will begin to form. Given that the lead concentration is this, once the Cl minus gets to this, a precipitate will form. But what about the other one, the silver chloride, AgCl? Well, my KSP for it is equal to 1.8 times 10 to the minus 8, 10 to the minus 10 is equal to Ag plus times Cl minus. Now notice again, it's Cl minus. So which one do I know?
AG.
Ag plus, so I can say that 1.8 times 10 to the minus 10 is equal to my Ag plus, which is 0.120 molar times my Cl minus. So my Cl minus here is going to equal 2 times 10 to the minus 9. So once the Cl minus concentration gets to this one, that's when the silver chloride is going to begin to precipitate. Which number is smaller? Which one is, as I'm adding this in drop-wise, which one am I going to get to first? This concentration or this concentration? The 10 to the minus 9th is much, much smaller than 10 to the minus 2, right? So it's going to reach this concentration first, which means that it's going to precipitate out significantly before this one does.
Is that it?
That's it for that one, but I'm going to add in a part. That's part A of that one. Okay? Now, the good news is they don't ask this one anymore on the AP test. Okay? Okay? No, this will be a bonus, like I said, all right.
So this is part B.
Okay? Now, this used to be on there. This was an old AP question. Okay, so it used to be on there, so it's worth going for. But I'm only going to spend just this little bit of time that we have left on it. Okay? So the question, the second part is, what is the ion concentration of the metal that precipitated first when the second precipitate begins to form? Okay? Now, they have to ask it like this because they can't give away. If they said a specific metal, they would tell you which one precipitated first. All right? What is the ion concentration of the metal that precipitated first? What metal precipitated first?
AG plus.
Well, the metal is Ag plus. Okay? What is that concentration when the second one, the Pb, begins to precipitate? Well, what's the chloride ion concentration going to be when the second one begins to precipitate?
1 times 10 to the minus
1.0 times 10 to the minus 2. Now I'm going to come up here and just, you guys can continue on, but I'm just going to go up here so you can see it. So we're worried about the second one precipitating, but we want to know what's the ion of the question is asking the metal that precipitated first. So I want to know the silver concentration. So that's going to mean I want this reaction, this equilibrium. So the KSP is still 1.8 times 10 to the minus 10. The question is, what's the silver concentration when the second one begins to precipitate? Well, what's the chloride concentration when the second one begins to precipitate? 1.0 times 10 to the minus 2. Now the good news on that one, we can do this in our head, is that this is going to be 1.8 times 10 to the minus 8, right? So there's only that much silver left in the solution. And then another question one year said, well, what's percent left? Well, what's the percent silver remaining? How do I find that? Part, what's the part? 1.8 times 10 to the minus 8. What's the whole? 0.12, what we started at. Times 100. Can someone give me that number?
1.5 times 10 to the minus 5%.
1.5 times 10 to the minus 5% remains. Not much, right? This is called selective precipitation. You can,
You divide, you divide the 1.8 times 10 to the negative 10 by the 1.0 times 10 to the negative 2?
no, by the amount that you started with.
Okay.
You want to know how much of the silver remains? Well, we started with 0.12. Okay?
She's talking about the original, where you're solving for the initial.
Yeah, I did this divided by that.
Okay.
1.8 divided by 1 is 1.8.
Okay, yeah.
And then 10 to the minus 10 divided by 10 to the minus 2 is 10 to the minus 8. Okay? Now, so what we can do is the selective precipitation. That's what we're going to do in our lab on Monday. Is we're going to have a mixture, but we're going to use, have to have some kind of indicator, and I'll talk about that tomorrow. All right. Yes, but that concludes everything in equilibrium.
So what are we doing tomorrow?
Practice.
When will our test on this be?
I would love to have a test on Monday, but the lab's gonna be Monday, a test on Wednesday.
Oh, we should have a test on Tuesday.
But no, but when you, and you're forgetting the minus 2 because, huh? Yeah, because when you go, it's, when you do exponents, it's 10 to the minus 10th divided by, I know, but it's not when you divide, you subtract them.
Alright, remember to like, comment, and
So
subscribe.
it's minus 10 plus 2.
We are going to end the video.
Yeah.